What I wanted us to cover today is what we have on data structures and algorithms. And since we had done something to do with C programming, it only makes sense to just continue some of these things with the particular language that we are already used to. And when it comes to data structures and algorithms, these really form a huge basis of solidifying your skills in programming, especially in programming in general. These are what makes systems to be very efficient. This is what makes something like when we do a Google search and say something like data structures and algorithms. When we do such a search in a very short span of time, Google is able to give us a million of results exactly. So you can see the number of results that Google got, it was about 200 million results. You can see it's about 200 million results in literally milliseconds. This is 0.21 seconds. This is even less than a second. So within less than a second, Google was able to find more than 200 million results. And the reason why is because of their very optimized searching algorithms. And that's why when you want to get into the roles for such big companies such as Google, Microsoft, IBM, Amazon, you have to go through a very rigorous data structures and algorithms test. And the reason is they know that if you have a solid foundation in DSA, or what we call data structures and algorithms, you can be able to build quite a ton of efficient systems. And that is the exact same reason why you see that these systems are efficient. Even if I search efficient, even if I search for such a word, you'll see that it will show us so many results in literally less than a second. This is 1.4 billion results. And if you scroll down, you can go to you can see we have different pages of Google. And people joke that the nuclear codes or this so many things that the world does not know about is hidden on the second page of Google. And that is because people don't look at the second page of Google. Barely you'll ever find yourself looking at the second page. So people just joke about and say that the nuclear launch codes are stored in the second page of Google, or the cure of cancer is literally on the second page of Google. But it just shows you that the efficiency with these systems and the reason why they are such efficient. 1.4 billion results in 0.22 seconds, and this is out of a search query. So they are using a very efficient searching algorithm when it comes to their search engine, which is Google, and then they index so many pages. And those are some of the things we'll learn how to build. And we can just start by the basics. And the basics is you remember us doing a hello world program, and when I just run, you can see the output is hello world. That is just printing out something. If you wanted to say today we are learning about data structures, you just say printf, and then you say today we are learning about data structures and algorithms. And then you ensure that you have your semicolon at the end, and whatever you output on the printf, that is what will be output on the console. So you can see hello world, and then today we are learning about data structures and algorithms. If you wanted to have a space, because I see that there is no space between this line, what I can do is I can come here and add a space by using the line feeds backslash n. This means I am introducing 3 lines or 2 that you will see. So you can see we have now 3 different spaces, these 3 lines that I have actually done. So let us get started with some of the basic data structures and algorithms. So since today's session won't be that long, I think we can just dive right in, and then we'll just look into the other things later. Let's say when we meet in class or in the sessions to come. And today I wanted us to start on some of the major algorithms or some of the major things that we have in DSA. And some of the major things that we have are what we call searching and sorting. So in the case of searching, when I went here at the Google website and searched a word like uh, efficient or data and AI, if I just do such a search, I get the results 2.5 billion. This is a search. And for search, we are using searching algorithms. And these two work hand in hand. If I can tell you how maybe this one works for Google, what Google has done is that in their database, they have billions and billions of data, billions and trillions. It's a trillion billion. I'm pretty sure it's a gazillion amount of data. And now you using a gazillion in the literal sense. They have such a ton of data. And the way that the way that they are able to retrieve such a ton amount of data is that the way they store their data, they must have sorted it in some way. By sorting, we mean arranging your data in a particular order. And the way they might have sorted it is they have so many different ways that they know how they sort their data. Maybe if one would want to know exactly how that is, they can liaise with someone they know who works at Google. But they definitely have sorted their data because they can't have just data being stored just like that. People Kenyans would love to say something that like how is it store data just like for they can store data just like that. They have to put into consideration how will I be able to retrieve this data that I am storing. And one of the best ways to store your data is to sort it in, let's say, either ascending or descending order. And in our case, we can store different data, be it in ascending or descending order. This means that maybe when I want to now retrieve the data, let's say let's say it's a data of numbers, IDs. If I sort it in an ascending or descending order, I can be able to have some really efficient algorithms that can be able to help me to search and retrieve that data in a very short span of time. Unlike if I had not I had not stored my data correctly, or maybe if I hadn't stored my data in a unsorted way. So what we will do is we'll actually do something to do with searching and sorting. So let us actually start with searching. Let's say we have a data of some data of numbers. Let's say numbers. What can we have? Numbers. Let's just stick to the basics and say we have just a bunch of numbers. Let's say random numbers between 1 and 100. So what I'll do to store our numbers, I'll just create an array of these numbers. So I'll just say int numbers. So it's an array is equals to, I can initialize the array and say 32, 43, 22, 1, and then I can say 43, 55, 76, 69, 99, 112, 43 is already there, 46, and then 20, 25. So let's say we have these numbers. These are my numbers. And how many are they? They are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 numbers in my array. So this is just a very simple setup. But now think of these numbers as the way the Kenyan government would store your ID numbers. Okay, let's say it was storing your ID numbers. They would be now something like this, where the numbers are much larger. But this is just a very simple case. And now after storing these numbers, what you can do is we can display these numbers. So how many are they? One, two. We say there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers. It's good to know the size of our array being number 12, being 12. And what I can do is I can display these numbers to the console. And for us to display these numbers, we can use a simple for loop. We can use a simple for loop to display these numbers. And I hope you can clearly see my screen. I don't want anyone to be left behind. So what we'll do is we can display these numbers. Let us try to display these numbers. And for us to display, we can say int I will be what we will use to display the index. We say that I is normally, we can use I to represent the index. And then we'll start index 0, index 1, 2, 3. That is how arrays normally are. And the numbers are 1, 2. So this is index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And the reason why it's 11 is because we are starting to count at 0. So if I wanted to display these numbers, I can say I is equals to 0, 0, and then I is less than the total number of these numbers is 12. So we say I is less than 12. And when you say less than, it means that we will go up to 11. There is a difference between less than and less than equal to. Less than equal to. When you say less than equal to, we go up to index 12, which index 12 is not there. So this 12 is majorly representing the size of the array. The size of the array, let me just get rid of that. The size of the array is 12. And then we do some I plus plus. And then we do that. And what we can do is we can now display these numbers. So we can actually display them on a single line or on multiple lines. It just depends on how you will print f or how you'll do your printf. So you just say printf, and then we printf what? So we can say index. I think we can say index 0 is this. Index 1 is this, index 2 up to index 11. So you can say index %d, because I want to replace this index 0 with a value that is of I. And then index 0 is equals to %d. And then you go to the, we can then go to the index 0 is equals to %d. Then we can do that, and then close. What I want it to display is index 0 is 32, index 1 is 43, index 2 is 22, exactly that. And how we do that is say index %d is %d. This is how you are saying things like total is equals to %d, and then you display the value of the total. And in this case, I just want to say index blah 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 is blah 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 is that value. And then outside, I will say, where does the first %d come from? It comes from I. And where does the second %d come from? It comes from, now the numbers, this array, these numbers, you say numbers index I. So numbers index I, what it will do is it will come to these numbers value and then replace the value of I. And when the loop starts, the value of I will be 0. So numbers index 0 will be 32. Numbers index 1 will be 43. Numbers index 2 will be 22. And when I print these out, you'll see that it won't display quite well because I haven't added a new line. So you can see how it's displaying. It's not formatted quite well. Index 0 is 32, index 1 is 43, but the reason why it's displaying like this is because I haven't added a new line over here. So I should just add a new line, and then we say it will now display perfectly. So we just say that, and you can see our beautiful numbers. So index 0 is 32, index 1 is 43, index 2 is 22, up to index 11, which is 25. And that is exactly what we had on our array. So you can see it's actually quite simple and it's displaying exactly how we want. Index 0 is 32. Then this is now just the displaying our numbers. And then you need to understand how this is working, because this actually lays the foundation when it comes to searching for our numbers. So now let's say we now needed to actually search for a particular number. We actually needed to search for a particular number. What this loop does is it actually displays all the numbers. And then now, let's say we now want to tell the user to search for a particular number. So what we'll actually do is we can tell the user, please enter the number that you want to search. So let's say this was our data. This was the data that we had. And I told you that this data might be any kind of data. This can now be substituted to how the government stores your ID numbers, how the banks store your IDs or different bank account numbers. It can equate basically to anything, because this is just the basis of the foundations. When you get these concepts, it will be quite easy for you to actually apply these things in real life. So what we can tell the user is we can tell the user to printf and ask the user, please enter the number that you want to search for. Please enter the number that you want to search for, and then we can go to the next line and ask the user to enter a number. So now when it comes to now this is now building on top of all the basics that we had learned on C programming. And how do we get the input of the user? For us to get input of the user, we use scanf. That is exactly something that you had learned on your theory or in introduction to C programming. And the number, we also need to store the number that the user will enter. So we just say int user number is equals to, you can equate it to anything to 0, but it's not necessary. It's not necessary. We can just I can leave some space. We can just use this user number and then scanf that number. So we just scanf. What is it? It's an integer. It's an integer, and we say that for you to scan an int, you say %d. So you scanf %d, and then you do a comma, and then you do and user number. User number. This is the exact same number that you scanf. So this is the syntax of scanf. Never forget this, because this is exactly what you'll always be required to do when you're scanning. And what you can do is we can actually display the number that the user has entered. So you just say printf the number you have entered this is equals to %d, then come on, then and then outside you say user number. You can see when we are printing out or when we are using printf, we are not using this and symbol. This and symbol is normally used when you're just scanning. This and symbol is majorly used when you're scanning. You have to use that and. But when you're displaying, you just display it exactly as the variable states. And because this %d will go look for whatever has been specified outside. If we had 2%d's, like in the first case, the first %d, it will be equated to the first that you specify outside. And then the second %d will be specified by the second one that you specify outside. And here what we're doing is we are scanning for that number, and then we print out and say that the number that you've actually entered is that exact number. And then we can actually just now we can run our program, and what it tells us is that please enter the number that you want to search for. So if I enter a number like 90, it should tell me that the number that you have entered is 90. That means that we've been able to capture the user input. And you can see the number you have entered is 90. Is 90. So the number that you've entered is 90. Now what we want to do is after the user enters this number 90, we want to search for that number 90 on this list. And if we find that number 90, we tell the user, we have found your number 90 at the index 8. Okay, of which that's not true. In this case, if we enter number 90, it should tell us that we did not find number 90. That is the exact same thing that is the thing that we want to do. The number that you've entered is, we can go to the next line, and please enter the number that you want to search for. After you enter, it tells you the number that you've entered is that exact number. So we just do that again, and in this case we say number 45. 45. So you can see it's telling me that the number you've entered is 45. So there's no number 45 on this list, but I can see we have two number 43s. So to keep it simple, I'll just change 143 to be 45. 43 to be 45. Yes. So now we should have 43 and 45. So let's say the number that you want to search for is 43. Here it says the number that you've entered is 43. This is just displaying. And then what we need to do is now do a search algorithm on our number. And now that will introduce us to the first thing, which we call now the searching algorithms. And in the first instance, after it tells us the number that you've entered is 43, what I need to print, we now need to now search for that number. So we just say printf and then say searching for number percent %d. In this case, I want it to say searching for number %d. Then we go to the next line. Then here, user number. So if you've entered number 43, it will say searching for number 43. I think we can even do the the loading dashes. So I hope we are all together on how this is progressing. So you can see how we are progressing onto this program. And now let's say we want to search for number 24. What it will tell me is that the number you've entered is 24, and then it will display searching for number 24. The number you've entered is 24, then searching for number 24. Please wait. We can just add anything that we want, and then what we now need to do is to search for number 24 among all these numbers. And if we do not find number 24, we tell the user that we did not find your number 24. And if we find your number 24, we tell the user that we actually found your number 24 at the index 4, at the index 8, at the index 11, whichever the index, we tell the user whichever the index that we found that particular number. So now after doing that, here, so we say here is where we now start the searching algorithm. In this case, we will use a linear search algorithm. Now, what we mean by a linear search algorithm? Now, for a linear search algorithm, what a linear search does is that it linearly, the same word that it's called, it just linearly searches these things. It will linearly search for the number itself. It will linearly search for the number itself here from start to finish. So for a linear search, we assume that for the worst case scenario, it will search through all the elements of your data. And that's why we say for a linear search, its time complexity is O of n. When we now start with the big O notation. For a linear search, it's O of n. And what we mean by now O of n is that it will linearly search through all the elements. That is, if the worst case scenario is when our element, so let's say we are searching for number 25, it has to linearly go through all these numbers up until it will get to number 25. But let's say we were searching for a number like 45. You see, searching for a number like 45, it will actually be quite fast because 45 is found at the beginning of our data. So that means that it can sometimes be fast and it can sometimes be quite slow based on the particular element that we are searching for. If we are searching for an element that is actually quite far on our input, it means that it means that the algorithm won't perform quite well. And that is exactly what now we mean by a linear search. So we'll start by searching the first element and see whether it is what we need. If it's not, we proceed to the next. If it's not, we proceed to the next. Next, up until we get to the exact number that we got. And that is exactly what we will do. And for us to search, you've seen that we have to go through all our numbers. And in this case, that is exactly what we'll do. And what we'll do, we have to use a for loop. So we have to use again a for loop. We say for, we can use, do we use I or uh, I don't know whether the compiler can't allow us to use, but what I can do is I can reset the value of I and then use it again. I can say I is equals to 0. Okay, I can reset the value of I because this I was just being used for displaying our numbers. What I can do is I can reset the value of I to be 0. But if you're, let's say, now writing your own program and you don't want to display all these, you can just say int I again is equals to 0. So we can reset I to be 0 and then say for I is equals to 0. Actually, I think even there is no need to reset it outside because we can actually reset it on the inside of the loop. So you just say I is equals to 0, I is less than 12, and then I plus plus. Plus plus, and then we open and close our curly braces. So now what we're doing is we will go through our this array, these numbers array. We go through these numbers array and then we search for the particular number that the user has input. And how we do that is just very simple. Because we are going through, because this loop will go through our numbers array, and actually I think I hope we are still all together. If you have any questions, if you have any questions, you can shoot them up on the chat if you have any questions. Yeah, I see that we still here. So data structures, and then now we want to go through all the numbers, and what we need in this case is to determine if this number at this index is the number that we have input here or the number that we have scanned up here. So it's very simple. You just say if the number, if the number's index I is equals to the number that we have input, which is the number, user number. We just say if the number's index I is the user number, what do? We say we have actually found that number. So this is a very basic type of search. These are very basic type of search, and what it does, it just uses a simple for loop, and equates when it finds the number that we need. If it finds that number to be the number that we need, it does whatever we will tell it to do. And in this case, we will say that printf will printf and say that your number, let's say you've input number 25, we'll say that number 25 has been found at the index 0 or at the index 20. And then you say number, your number, percent D, your number 25 has been, or we can say found at index percent D. So you say, and this logic, just what you need to understand is what is happening right over here. What is happening right over here is that we are saying the numbers index I. So what this means is if I is 0, it means numbers index 0, which is 32. Numbers index 1 is 45. This is what the for loop does. It starts from 0, 1, 2, 3, 4. Think of these as the values of I. So I0 will be 32, I1 will be 45, I2 will be 22, blah, blah, blah. Continuing up to I11, because we are saying less than 12 and not less than or equal to 12. So I1 will be 32. And then we say I1, 32, is it equals to the number that we've entered, which is 25? No. What it does, it will not execute this. It will go to the next number, I2. I2, 45. Is 45 equal to 25? No. It will go to I3. I3, 22. Is I3, 22 equals to 25? No. And then go to I4, I5, I9, I10, I11. So is I10, 99 equal to 25? No. If it doesn't, if it doesn't find a number inside this loop, we are going to tell the user that your number was never found. So we just finish up this sentence and say your number percent D. So the first percent D, your number, the first percent D will represent the user number. And then the second percent D found at index 0. Index 0, index 1, it will represent I. And then after finding that number, there is no reason to continue looping. So we can just break, because now after we found our number, there is no reason to continue looping around. We just now break. And what this break will do, it will break out of this for loop. So the break statement is majorly used where there are loops, and where there are loops also in the switch case statements. That is where you'll find us using the break statement. And what we are going to do is that now if we have found your number, we break. But what what it means, I want also to display, when the number was not found, and I'm looking for the best way to tell the user if the number was not found. So this will happen. Okay, what will happen, let's actually do what, let's actually first of all run this program before we even proceed, so that you can see how it's working. First of all, you can say these are our numbers. Index 0 is 32, blah blah blah. Index 8 is 99. So let's say we want to find number 99. What we'll do is input number 99. And when you input number 99, in this case, personally, I expect that it will find our number 99 at the index 8, because our number 99 is actually there. So when we enter, you can see the number you've entered is 99. Searching for number 99, and you can see it has told me your number 99 was found at index 8. Exactly what we have here. We have here, so exactly what we have here. We say your number, whichever number you've entered, has been found at index, the exact index that it has been found. So that is exactly that is exactly what what that means. So let's do for another number, and also here we can do a line. We can skip a line. We can skip maybe two lines and also let's look for another number. And in this number, let's look for number one, which is at index 3. So number one is at index 3. So just input number one, and the number you've entered is 1. Searching for number one. Your number one found at index 3. Exactly what we have here. So this is what we call a linear search. This is what we call a linear search algorithm, and it's very simple. It's like the simplest of them all, because you just loop through all the elements of your array, or you just loop through all your data, and then if you find at a particular index that is the exact same data that you're looking for, in this case the user number, you just tell the user that that number has been found at that particular index. So let's look for a number that is not on this list, and the number that is not on this list, the number that is not on this list, let's say we now input a number like 67. 66, I think is there. Is 66 there? No, 66 is not there. In this case, 66, since 66 is not there, it will not tell us this. It should not tell us your number 66 has been found at index. It will just not do that. It will just come up to here searching for number 66, because it will come here and see that it doesn't find any number, and the loop will end and the program will end. So the last thing I expect to see is searching for number that backslash n. Let's enter and see how the output will be like. You can see the number you've entered is 66, and then searching for number 66, and we do not have another output. So, but it's always good to tell the user if the number has been found or not. So if the number has been found, you tell the user that your number has actually been found. If the number has not been found, you tell the user your number has not been found. So there can be different ways for you to tell the user whether their number was found or not. There are different ways to do that. So anyone who might have an idea of how we can tell the user that their number was not found, because one of the things you can do is you can what can you do? Anyone who has an idea, you can hack around and see how you can tell the user that their number was not found. So if anyone has an idea, they can they can shoot it up, or they can unmute and give us an idea of how we can actually tell the user that the number was not found, because those are some of the questions that you can be asked, major not in an exam, but majorly on an interview. In an exam, you'll actually be told to just write the entire program, but let's say in an interview, you can be asked to say, when a number is not found, what would you do? How do you tell the user back? So there are a couple number of ways. There are a couple number of ways to tell the user whether a number was found or not. And in other different programming language, you can use something we call a boolean, bool, okay, boolean, or in a language like Java is called a boolean. So a boolean is what we call, it holds a value of true or false. So let's actually see. So bool, we can say bool is found. So bool is found is equals to, I think in C the value should be either 0 or 1. 0 representing false, 1 representing true. So let's see whether it's actually we can even actually research right now and say bool data type in C. You can see the bool data type, it's to represent the boolean values which can either be true or false. And exactly what I was saying is if it's false, it's 0. If it's true, it's 1, which is represented by the integer value 1. So what you can do is you can use this boolean value. You can use this boolean value. And what you can do is now we can say boolean, we can say bool is number found is equals to false. This is the same as saying that the number has not been found yet because we haven't even started searching for our number. So we say is number found, and the reason why I'm saying that is, it's just like a programming convention. When you're naming your boolean values, you name them as a question. It's not a must. It's not a must. It's not a must you just say is number found. You can name it to whatever you want. You can even say found, found. Okay, you can even say found. But in programming, you're just advised to be as descriptive as possible. So you can say is number found, is number found. And in this case, I'm saying that the number is not found by saying is number found is 0. And then what we now need to do here, after our number has been found, we set the value, of is number found to be true. So we just say is number found is equals to true, of which is 1, 0, and 1. You can see even Google tells us that the true is represented by 1 and then false is represented by 0. So you just say is number found, you start it at false, but when we find that number, we say that that number, the value is 1. So after the loop ends, you can say now here if, so you can say if is number found, is number found is equals to 1. If the number is found, if the number found is equals to 1, so this means that the number was found. When it's 1, it means that the number was found right over here. That means the number was found. So if is number found is equals to 1, you can say printf, you can give feedback to the user successfully and say your number was found successfully, and then you can go to the next, successfully, and then you can go to the next line, successfully. Your number we can still use %d, your number %d, and then it was user number. So your number percent D was found successfully. Awesome. Now, if it was not found successfully, that means it's else. Printf, you can say printf, your number percent %d was not found. Was not found, and we can was not found. And then we can go to the next line, and we can say user number, and then we can do a semicolon. So this is what will now tell us or tell the user that your number was found successfully or your number was not found successfully. So if the number was not found, it will come and tell us that your number 27 was not found. If number 27 was found, it will actually say your number 27 was found at index 0. And then it will also say your number 27 was found successfully. So let us just run the program. Let's just run the program and actually see. Bool is number found. What is it? What is it? What is it? Unknown type name bool. So actually, this is another thing. This is actually another thing that now I don't know whether I can maximize the errors right over here. So I thought you can typically use bool right out of the box in C. But remember when we were defining data types in C, we never said bool was a data type. We were saying it's int, float, double, char. Those are the major data types. You can see it's telling me there is an error, unknown type bool. So for you to use bool, it's telling me I have to add another preprocessor directive that is called std bool. Okay, stdbool.h. That is how I can be able to use bool, and that this just shows you how you can add a couple of different preprocessor directives. You say that these are the preprocessor directives. So for us to use bool, because I've tried to run my program and it's actually not working, because I cannot use bool just like that out of the box. For me to use the bool, I just need to include another preprocessor directive and say hash include, it's saying std bool, is called std bool dot h. That is, this is now what will allow me to use the bool. And I don't know whether let's see after doing that whether you can have something like true or false. Okay. Uh, let's see whether we can say here to be true. Yeah, you can use true or false. Let's see. Let's just, it's just a matter of testing, because literally I have never used a bool in C. I normally use just numbers, either 1 or 0. So let's see whether it will actually build. Oh, actually, awesome, it builds. So it builds, and now the program should work perfectly. The program should now work perfectly. So I will now enter a number that I want to search for. And the number that I want to search for, let's say in this case, we'll start with the number 22. So 22 will tell me has been found at index 2. So the number you've entered is 22, searching for number 22, your number 22 found at index 2. And then the verdict that is final is that your number 22 was found successfully. Now, the major thing why we added that bool was to take care of the case if the number was not found. So we want to take care of if the number was not found. And what I'll do is I'll just run the program again and now have a case where a number is not actually found. Let's say a number like 78, 78. And you can see the number you've entered is 78. Searching for number 78, and then your number 78 was not found. Exactly what we expected, because the number 78, it wasn't in our list. Number 78 was actually not found, and that is the exact same reason it's telling us that number 78 was not found. And the reason why is because it's coming to this entire loop, and it's looping through all our elements, and that's why it's called a linear search, and its complexity is O of n. So never forget that the complexity of this is O, it's O of n. And this, we are talking about, I think, both the time and space, because the time, it represents the time taken to maybe retrieve an item, add an item. That is the time taken. Time and space complexity is O of n. This is what we call a linear of n. Let me undo, because now this is what we call the linear. This is what we call the linear time. This is what we call the linear time. We'll actually later look into others, the log time, the linear log, some of the other more efficient algorithms such as the binary search. You'll see that they have a better time, because it's actually more efficient to store data, and also to retrieve the data. Something like Google, you cannot use a linear search in Google. That is, not unless you would be telling people to wait maybe for 2 working days to get their results, for you to search for all the terabytes of billions of gigabytes of data that Google has. If you are to use search as a linear search, the reason why it's literally performing so well is because we have such few data. We just have literally just 12 elements of data. If we had let's say like 100,000 or a million in the data entry, and then we tried to search, you'll actually see that when we do a linear search, it's actually taking some time. It's actually taking some time. And I think when we continue next, I will try to set up a data set that is quite large. Quite large. Let me see, even number data set. Number data set. You can get a number data set that is quite large. I think these are for AI training. We can even try to write our C program to write random numbers to a file. We can write a C program that will write, let's say, a million numbers to a text file. And then after writing those million numbers, I think actually that is what we'll actually do. I will set up such a scenario so that we can see now how these algorithms work. And then we also write some code to time these different algorithms. We time, let's say for a linear search, we time it and see the total number of seconds that it takes to retrieve different data. Also for a binary search, we test and see we test and see the total time that it takes to retrieve data. So what we'll start by doing is we'll write a program that will write a text file, that will create a text file, and then write maybe a million different random numbers. And after doing that, we now start performing search algorithms on that text file that has all those different numbers, because I cannot sit down and write a million numbers. So you can actually You can actually try. You can do this as a trivia for yourself. You can write a C program. You can write a C program that creates a text file. You can write a C program that creates actually, yeah, you can do that because we will build on top of that. So you can do this. You can try to do that. Write a C program that creates a text file named um, random 1 million random numbers dataset .txt. So you can create write a C program that creates a text file named million random numbers dataset. So you can actually do this so that next week when we meet, we will all have this dataset that has a million random numbers dataset. So the random numbers should be, so these are all the things that you should be able to know. So you can say the text file will contain random numbers random numbers between, so the random number that is generated, random numbers random numbers these are different instructions. So uh, each generated random number should be between, so you should generate a random number that is between, let's say, 100 and 100 and 1000. No, and let's say 10,000. But now here comes another problem where I'm pretty sure that I'm pretty sure that what do you call it? I'm pretty sure that if we do this, there will be so many repeated numbers because of what you call the pigeonhole principle. If you're generating a million numbers, and we are generating between 100 for each random number, we are generating 100 to 10,000. That means that we'll have multiple repeated entries. So I think what we can do to make it very simple, million random number dataset, the text file will contain, let's not do random numbers, will contain the numbers from 1 to 1 to 1, 1, 2, 3, 1, 2, 3. So from 1 to 1 million. Each number, each number is written on the next line. So you will have a text file that is a 1 million, 1 million, 1 million, 1 million lines. I don't know whether text file will support, but you can just try. If 1 million does not work, reduce it to 100,000. Reduce it to 100,000. If let's say 1 million does not work, you can reduce it to 100,000. It will just be a change in 10, so you can reduce it to 100,000. So yeah, you can write this program so that we can now use it as, let's say, our data set, so that we can see if we wanted to search for the number the number 982,000. When we use a linear search, we time the linear search and see how long it will take. And if we let's say want to find that same number using the binary search, we see how the total amount of time that that algorithm will take. So these are some of the things we can do and we'll continue doing. Yeah, so I think that's it for today. We have just 2 minutes. I will send this text to the class rep so that she can forward it to you. Million random number dataset. Million number data set. So let's remove random because we are not doing random numbers. So we can say million numbers data set. Million, million, 1 million. So you can try a million if the program does not allow you to write a million values on a single text file, just reduce it to 100,000. I'm pretty sure 100,000 will be able to be written, but start with a million, see whether the program will write. And then we'll be using that to test out these searching and sorting algorithms. So that is it for the session today. Maybe if we have any questions, the session has been recorded and I will be sharing it later as an unlisted video or something. Yeah, I will be sharing the recording for those who want maybe to look back into what we have talked about. So yeah, that is it for the session. I'm pretty sure you have another session at 10. That's why I didn't want us to take so much time. Yeah, so that is it for today. I think I can stop the recording right there.